Hi everybody, and welcome to my first video that covers section 1 of chapter 3, and in this section we are going to discuss measures of center. It turns out that there are 3 measures of center that we're going to discuss in this particular chapter. The first one is the mean. That is probably the one that is most familiar to all of you. The second 2 are the median and the mode. Both of them have different properties and behave very differently under different situations and are also more ideal under different situations. This particular video we are going to cover the mean. In the next video we will cover both the median and the mode. Well, as you've noticed from the previous slide, there are 2 types of mean. One is called the population mean, which is given the parameter mu, and the other one is called the sample mean. I'll give you a sneak peek of it right here. There it is, with the symbol x bar. The population mean is exactly what it is. It is the average of all the data values in an entire population. And how do you compute the average? Well, what you do is you take data values, you sum them up, and if there are n of them, you divide that sum by n. It's something that we've all done before in various situations, and it really is no different here. Now, I do have this cute little compact notation for you, and basically this symbol right here is called sigma, and you'll never guess what sigma stands for in this particular case. It stands for, you guessed it, sum. So basically, if we sum up all of our data points, we are doing this, and then the only thing left is to divide it by n. And notice here, capital N is the numbers of values in an entire population. Now, if you don't have access to the entire population, which is usually the case, particularly for large populations like all the citizens of a given state, then you probably only have access to a sample of that data. And in that particular case, the mean that you're going to compute is going to be the sample mean. That is the average from a data set that is sampled from an entire population. Process is entirely the same. What we do is we take all the samples, we add them up, divide them by the number of samples. This basically means the exact same thing again. This is nothing more than a compact way of saying we're adding up all the numbers. Why do we have a different notation? Why do we have x bar here and mu for the population mean when the procedure is the same? Well, it turns out that even though the procedure we're coming up with the mean for a sample or a population is the same, in a follow-on section when we talk about standard deviation and variance, the approach for finding those 2 values is different. So because they're different and they have different notations, we basically try to separate the sample, the symbol for the sample mean and the symbol for the population mean. Okay, now we also have a rounding rule for the mean, and it's basically this. If your data set has a certain number of decimal places, then your mean has to go to 1 additional decimal place. Okay, for example, here we have a sample set, or we have a sample. We have integer, something to the 10th, something to the 10th. So our sample mean must be rounded to the next higher decimal place, which would be the 100th. So sometimes you will have to follow sometimes in your homework you will have to follow this rule. Other times they will tell you exactly how many decimal places they want you to round. However, if they do not tell you that, you need to follow this rule, which basically means add another decimal place. Now it is time for some examples. Okay, so here, students conducted a study of undergraduate sleep habits during the semester, and below is a sample of their survey. So obviously we don't want to find the population mean, we want to find the sample mean. How do we do that? Oh, and by the way, here are our numbers. How do we do that? Using the formula we had before. We take the numbers, we add them up, divide by 7, because you guessed it, we have 7 numbers. These numbers sum to 48. 48 divided by 7 is 6.85 and some more stuff. Since these are all integers, we want to round to the 10th place, so our answer will be 6.9. Now, the last thing that we need to talk about is the weighted mean. And if you've ever computed your GPA or looked at your GPA, hey, guess what? That's a weighted mean. What is your final grade? How do I compute your final grade for this course? You guessed it. It happens to be a weighted mean. And what does that mean? Well, that basically tells us that each data value has different importance. Obviously, your score for your homework, which is half of your grade, has a higher importance than your score for your tests, for all of your test average, which is only 30% of your grade. And this is shown by assigning a weight. So here would be your data set, and here would be your weight. And what you would do to compute a weighted mean is you would multiply your data value by its associated weight, add them all up, and divide it by the sum of the weights. You will notice that when we are computing the sample mean or the population mean, we actually are assigning weights to each value. The weight happens to be 1. In the most general case, the weight can be something other than 1, and that's what we need to deal with when we're dealing with weighted means. And what is the best way to do this? Well, I'm glad you asked that question, because I'm going to provide you with an answer using an example. So here we go. This is our class, and in our class, the final grade, I kind of think I forgot the E there, is computed as follows. The homework is 50%, the tests are 30%, the final exam is 20%. And now, for this particular case, we want to calculate the grade for a student with the following average scores. He aced the homework, got a B on the test, got a on his test average, and got a B on the final. So what will his final grade be? Well, to compute this, the best thing to do is probably to create a table. So here's what I'm going to do. I'm going to create a table of our data values. Okay, I'm going to create a table of weights, or the next column is going to be weights, and then the third column is going to be the product of the data value times the weight. Now notice that we have homework, we have tests, we have a final exam. Now in our homework, we have 100, that's our data value. The weight associated with homework is 50%, so I'm just going to put in 50. We could put in the decimal equivalent, but there's no reason why we would have to. And then finally, the product of those two is going to be 5,000. Now for my test, I got an 80, my test average. The weight for that is 30. The product of those two is going to be 2,400. And then finally, for my final exam, I got an 80. It was weighted at 20%. The product of the two is going to be 1,600. Okay, now that I've done this, I want to compute the sum. I don't care about this sum. That sum means nothing to me. This I want to compute, and this will sum to 100. And this right here sums to 9,000. So what is the weighted mean? Well, the weighted mean is going to be the quotient of 9,000 and 100, or specifically it's going to be 9,000 divided by 100, which will be equal to 90. So if I ace all of my homework, get every single one of my homework assignments in on time, and only manage a B on the midterm and the final, hey man, I get a 90, and guess what? That's an A in the course. For my next example, well, suppose that I handed in every single homework problem late and aced aced all of my exams and the final exam. What is that going to look like? Well, let's go ahead and create our exact same table and see what we have. So we have data values, we have weights, we have the product, okay, homework, tests, final exam. Okay, so for my homework, I got a 70. The weight associated with that is 50%. That is 3,500. Okay, tests, I got 100. Associated weight, the weight associated with that is 30%. That gives me 3,000. And then for my final exam, ace the final. Associated weight is 20%. That gives me 2,000. We want to, forgot my other zero there. There we go. We want to sum. Don't care about this. This sums to 100. This sums to 8,500. So my final average, which is going to be a weighted average, is going to be this value, 8,500, my bad, divided by 100, which is an 85. So if you, and of course that's a B. So if you basically hand in all of your homework late, but before the start of the final exam, the best you can do in this course is a B. So what am I trying to tell you? I'm trying to tell you to do your homework. Do your homework and ace the course. That should be feasible for every single student in this course. And the last example that I have for this video is the dreaded grade point average example. So here, let me read this for you. I know you guys could read, but humor me. Suppose a student received the following grades. A for 6 credit hours, got a B for a 3 credit hour course, a C for a 3 credit hour course, and an F for a 3 credit hour course. So that we can almost assume that this person took 1, 2, 3, 4, 5 courses, got 2 A's, a B, a C, and an F. Okay, and note that an A, of course, in our GPA computations is associated with a 4.0, B is associated with a 3, C is associated with a 2, D is associated with a 1, and F associated with a 0. We want to compute our GPA and we want to round our answer to 2 decimal places. Now the thing you need to understand is that the data is the grade value. Not the credit hour, but the grade value. The weight is the credit hour. And it kind of makes sense because if you took 2 courses with an A, the A should have a higher weight than all the other courses. Okay, so to do this, let's just go ahead and create our magic table again. So once again, we have data, we have weight, and we want to compute the product. Okay, our data is going to be 4, 3, 2, 1, 0. Blast off. I sound like I'm doing a countdown. Our weights, well, we have 6 for an A. We have 3 for a B. We have 3 for a C. We have 0 for a D. And we have 3 for an F. So if we take the product here, we will have 24, 9, 6, 0, 0. And of course, you want to compute the sum. This one doesn't matter. This is going to sum to 15. And this is going to sum to 39. So our GPA is going to be 39. Yes, that actually is a 9, not a pathetic 4. It's a pathetic 9, not a pathetic 4. Divided by 15, which is equal to 2.6. So that is how we compute your GPA. You're going to see a couple of GPA problems in your homework, so get used to this because you will see it in your homework and I guarantee you you're going to see it on the test. And that is all I have for this particular video. Stay tuned for our next video when we are going to talk about the median and the mode. Until then, if you have any questions, please feel free to contact me. This is Bob Boyle, signing off.